everybody. In this video, we're going to talk about how to add and subtract fractions with area models and how to introduce this concept to your students in a way that will help them build conceptual knowledge around it. So if you're adding two fractions like 3/5 plus 1/5, you could ask your students when they haven't seen any addition of fractions to predict what they think the answer would be. And some of your students are going to say that the answer is 4/10, which is a reasonable guess because 3 plus 1 is 4, 5 plus 5 is 10. However, your students that give an answer like this don't have a really clear conceptual understanding of what fractions are. Because if you were to visualize 3/5 plus 1/5, that means that you have some shape. So I chose a pentagon that's split up into 5 pieces, and you have 3 of them shaded, and then you're adding another one of those pieces. And when you combine these together, you're going to have 4 pieces, but the denominator is going to be a 5 because the size of the pieces is not changing. Because the denominator of the fraction tells you how many pieces are in a whole. And you want to, like, when you combine these shapes together, you're not changing the size of the pieces. You're not suddenly making them tenths. They're still fifths. You're just combining them together. And when you're subtracting fractions, it's the same thing. Because if I have 7/9 and then I take away 2 of them by getting rid of 2 of them, then I have 5 pieces left, but the size of those pieces are still ninths. And so by helping your students visualize the fractions with area models, they'll start to build that conceptual understanding of why you don't add or subtract the denominators of the fractions. So now let's talk about what happens when you don't have the same denominator. Like if you have 2/5 plus 3/4, your students might say, well, I know that there's 5 pieces, but I don't know whether to call them fifths or fourths because some of them are fifths, but some of them are fourths. And this is a good question for your students to have because this is the reason why we have to find common denominators before we add or subtract fractions. So the way that we do this is we make the pieces that we have into smaller pieces. And specifically, we do this in a way that will make it so that the pieces in both squares will be the same size. So the easiest way to do this is to just multiply the denominators together. So I'm going to multiply 5 times 4, which means that I'm going to split up the 5 pieces that I have into 4 more pieces, which gives me a total of 20 pieces total in my entire square. Now, the 2 pieces that were shaded are now 8 littler pieces because each of the 2 pieces was cut up into 4 pieces. And so this shows us that 2/5 is equal to 8/20. And then for the other fraction, I'm going to do 4 times 5 because that was the other denominator. And when I split these up into fifths, like this, I end up with 20 pieces total again. And the 3 pieces that used to be shaded are now 15 pieces. And these squares are the same, or these rectangles, I should say, are the same size. Now, they might not necessarily look like it, but this rectangle right here is the same shape as this one. They're just turned sideways. So this side is 1/4, and this is 1/5 of the square side length. And this one is 1/5, and this one is 1/4. So when you're doing this with your students, you may need to like rotate the squares so they can see that they really are the same shape. Um, but whenever you um, cut up the shapes in this way, the little rectangles that are formed will be the same size. And so now that all of the pieces are the same size, now you can just add them all together and you can say, well, I have 8 yellow ones plus 15 purple ones. And when I add those together, I get 23 20ths. And this also can be used to show how to convert mixed numbers because I could take these 5 right here and put them into these spots. And then I would have 3 left over. So you could also convert this to the mixed number 1 and 3/20. Now let's say that we have another question like this one. So in this case, we have 3/8 plus 1/6, you could use the same strategy we did on the last slide, where you would say, okay, I'm going to do 8 times 6, which splits this shape up into 6 pieces like this. And the 3 pieces that were shaded before are now 18 of these new pieces, and there's 48 of them total. And then for the second fraction, you could do 6 times 8. Sorry, that was a weird 8. And that's basically cutting these pieces up into eighths like this. And that gives us 8/48. And then when we add these together, 18/48 plus 8/48 is going to be 26/48. And because the top and the bottom are both even numbers, we could reduce it by dividing the top and the bottom by 2, which would give us 13 over 24. That would be fully reduced. So you can do it this way. However, there is an easier common denominator that you can find with 8 and 6, and that's known as the least common multiple. So the least common multiple is basically a multiple that 8 and 6 have in common, but it's the smallest one. So if I were to list out the multiples of 8, I'd have 8, 16, 24, 32, 40, 48, 56, and so on. And if I list out the multiples of 6, I'd have 6, 12, 18, 24, 30, 36, 42, 48, 54, etc. And notice that 48 is a common multiple of them, which makes sense because 8 times 6, if you make 6 copies of 8, obviously that will be in your list of multiples of 8. It will be the sixth one. If you make 8 copies of 6, it's going to be the eighth copy of 6. So those are common multiples, but the least common multiple is the number 24. And this is the simplest fraction or the simplest denominator that you could convert these fractions to. If you decide to use the least common multiple method, I would highly recommend that you use circle models instead of rectangle models, because rectangle models technically still work, but the size of the little rectangles that are formed may not look like they're the same because they'll have different proportions. So it would still be 20/4 because the whole square is cut up into 20/4, but they won't necessarily look like the same shape. So it's up to you. You could also do that later on and ask them why these shapes are not the same, but why they're still equal. That could be a whole nother discussion. But when you're first introducing it, I would recommend using circles if you're going to do the least common multiple method. So to do this, you just think about, well, what times 8 equals 24? That's 3. So I'm going to multiply 8 times 3, which means that I'm cutting up each of these pieces into 3 equal sized pieces, which will give me a total of 24 pieces in the entire circle. So I have this. And then if I multiply the numerator by 3, that tells me that I have 9/24 in that shaded space where I used to have 3/8. Then, same thing with 1/6. I'm going to say, well, what times 6 equals 24? That's 4. So I'll do 6 times 4, which means I'm splitting up each one of these 6 into 4 smaller pieces to give me a total of 24 pieces in the circle altogether. So, looks like that. And that one piece that I had shaded before is now 4 pieces that are smaller. So I have 4/24. And now that I have that, I can do 9/24 plus 4/24. And notice that we get the same answer as we did on the last problem, but it's already fully reduced. Now, this won't technically always happen. I specifically designed this problem in a way so that it would. Um, Sometimes you will still have to reduce, but you won't have to reduce as much. So the least common multiple method is one of the more efficient methods, but I would recommend starting off with what we were doing before, where you just multiply the denominators together. Because the main idea is that your common denominator has to be a common multiple. And you're always guaranteed to have a common multiple if you multiply them together because they will be like that number will be a multiple of both of them. But sometimes there are multiples that are smaller than that, which just makes it easier for reducing. So I want to do one last example with subtracting fractions. So the process is very similar. The only difference is you're subtracting, and I want to show you how to show that subtraction visually. So if I have 2/3 minus 1/5, I'll go ahead and use the least common multiple method. And I'll list the multiples of 3, which are 3, 6, 9, 12, 15, 18, 21, and so on. And the multiples of 5 are 5, 10, 15, 20, and so on. And we've already got our least common multiple. Now notice that in this case, the least common multiple was also the product of the two denominators. So this will also happen. So sometimes they're the same method. And so the thing that I need to multiply by to make it so that they have common denominators in the case of 2/3 is the number 5. So I'm going to multiply 3 times 5, which basically cuts up each piece into 5 little pieces, which gives me a total of 15 pieces altogether. So when I cut those 3 pieces up into smaller pieces, the shaded pieces that I had, where I had 2 of them before, are now 10 of them. So I have 10 15ths that's equivalent to 2/3. And then for the 1/5, I'm going to multiply this one by 3. So basically cutting each one of these up into thirds like this. And the one piece that was shaded is now 3 of the little pieces. So I'm going to have 10 15ths minus 3 15ths. Now, at this point, all of the fractions, or both of the fractions, have the same size of pieces. And the blue pieces and the green pieces are now the same size. So to subtract them, I'm just going to show kind of like a correlation, almost like thinking about these as negatives that cancel out the positives. You wouldn't explain it to your students in that way because they don't know about negative numbers yet. But I'm going to say, okay, well, this amount is going to take away this amount. And this amount is going to take away this amount. And this one is going to take away this one. And what I have left is 1, 2, 3, 4, 5, 6, 7 of my 15s. And so this would equal 7/15. So that's how you can add and subtract fractions with area models. If you have any questions, let me know. And I hope you have a great day.